Start recording. There we go. Hydrolysis is just the reaction of an ion with water to produce an acidic or basic solution. Were we just doing things with ions and reacting them with water to get a basic solution? Yes. Would you know how to take NH4 and react it with water to get an acidic solution? Probably. That's all that hydrolysis is. Okay, so it's nothing to do with the biology hydrolysis. This is the reaction of an ion with water to produce acidic or basic solution. Only some ions can undergo hydrolysis. So for example, we've already looked at ones that can't. Can chloride undergo hydrolysis? Can chloride react with water? Is that possible? Is that a possibility? No, because we would get, what would we get?
HCl.
No. HCl, and that says, oh, no, okay? So some ions cannot undergo hydrolysis. Let's take Na, for example. What does Na do when you put it into water? Does it do anything? No, therefore it does not hydrolyze either. Okay, so lots of ions don't hydrolyze. We need to look at the ones that do and the ones that don't and how you tell. Okay, so only some can undergo hydrolysis. So if you place a salt into solution, the first thing you have to do is you have to dissociate it. And I like to call this, who are the ions? And then the second step is you have to look and say, can either of these hydrolyze? So this step I call, do they hydrolyze? Okay, so we have a salt containing Na and Cl. Does hydrolysis occur? If we dissociate NaCl, who are the ions? Yeah, Na plus and Cl minus. Do they hydrolyze? Does Na hydrolyze? It doesn't do anything in water. Hopefully you just kind of know that. Alkali ions do nothing, okay? The only two things they can do with water is they can either accept a proton or they can donate a proton. Okay, when you hydrolyze, it's going to either accept or donate a proton. If something accepts a proton, what did it act as? It acted as a base. That would be basic hydrolysis. You would end up with a basic solution. You would end up with OH minus. If whatever ion you have donates a proton, if it donates a proton, what did it act as? Acid. So you would have acidic hydrolysis and you would have an acidic solution because you would end up with H3O plus. And if it does neither, then there is no hydrolysis. Okay? So can Na accept a proton? Let's see what that would look like. This is super fun. We would end up with NaH2 positive plus OH minus. What do we think of that? Does that look good? So what we did is we took an H from here and put it there. That's the only way it could accept an H. Does that look reasonable? No. Okay, that's crazy. Can it donate a proton? It does not have a proton. How can it donate a proton if it doesn't have a proton? Doesn't have a proton. So Na does not hydrolyze. In fact, no metal ions hydrolyze. So if you have a metal ion, it will not hydrolyze. There are 3 exceptions: iron, aluminum, and chromium that we will talk about later. I remember these because I have a little mnemonic for it. Feel creepy. Okay, those are the only three positive, metal ions that hydrolyze. Otherwise, if you've got a metal, you can just ignore it. Therefore, ignore metals except feel creepy. Whoops, I put 2 R's in there. That's not good. Okay. Does chloride hydrolyze? We actually looked at this already, and we said, does it hydrolyze? Can it donate a proton? No, it has no proton. Cl minus has no proton. Can chloride accept a proton? We already wrote this. You would get HCl, which is strong. So the answer is no, it cannot do that. And I'm just driving home the point here by saying, look, on your chart, it's got a one-way arrow, it cannot accept. But you guys know that already. So none of these 4 ions at the top, or not 4, 6, none of these 6 ions can hydrolyze except HSO4. Why am I writing S like that? And how would HSO4 hydrolyze? Would HSO4 accept a proton? No, it would do it by donating a proton. So maybe we should say none of these 5. Maybe that would be better. So if there is no hydrolysis, the solution will be neutral. So if I give you a salt, what you're going to have to do is you're going to have to look at both ions, the cation and the anion, and if neither of them hydrolyze, the salt will be neutral. Let's look at cations in specific, because there's cationic hydrolysis, where the cation accepts a proton or donates a proton, is very rare. The only 4 cations that do hydrolyze are feel creepy and ammonium. And that is because they all have hydrogens. And if you're like, hey, hang on, iron doesn't have hydrogen, aluminum doesn't have hydrogen, chromium doesn't have hydrogen. If you look on your acid table, let's go grab that. There are 3 acids that have big, long names. Okay, we have big, long name number 1, big, long name number 2, and big, long name number 3. And you can see that when iron acts as an acid, it's not just iron, it is iron along with a bunch of waters. How many waters? 6 waters. How are you going to know that? You're going to remember feel creepy and you're going to look it up on the table. Okay, you don't have to memorize that it's 6 waters. You don't have to memorize that formula. You don't even need to know what it turns into afterwards, because what it turns into after it donates a proton is also given on the table. Yes? Why 6? Just because it does.
No, I meant like why is H2O?
It has to do with empty d orbitals, which means nothing to you. So can we just move on from that? Okay, cool. Cool. All right. What on earth happened here? That's weird. Okay. So we have the hexa-aquo. Why is it called hexa-aquo? Hexa means 6. Aquo means water. And that means we have 6 waters attached to the iron. Same thing for aluminum and same thing for chromium. The hexa-aquo aluminum and hexa-aquo chromium. Not hard to remember because they are written down for you on the table. So you can remember feel creepy, or you can remember to go look for the longest names on the table. There they are. Okay, longest names on the table. And also ammonium. If you look on the whole table, the only positive ions you'll see are 1, 2, 3, 4. Everything else is either neutral or an anion, right? You can go down the whole list. Neutral, 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 neutral. Oh, we got an anion in there, some negatives, neutral, some negatives, negatives, neutral. Nothing is positive except for those 4. So let's just practice writing the formula so it doesn't seem so weird. Iron gets together with 6 waters and becomes Fe. We put the water in brackets, H2O6. And we still have that 3+ charge, so that 3+ charge stays there, and that is aqueous. Is good? Okay. Here is how the waters arrange themselves. They just kind of, the lone pairs on the oxygen slot into some empty orbitals on the metal ions. You are not responsible for these drawings. The only thing you need to know is that the attached waters provide loads of lovely hydrogens to donate. So now these guys become acids. So although you can just look this up on your table, let's practice doing it. Let's take this hydrogen here and move it over here. So as our product, we will have Fe. After a hydrogen moves, how many waters do we have left? We had 6 waters. Now we only have 5 waters. Why am I writing it like that? That's not how we write it. We write H2O5. And what's left over from that 6th water after we remove the hydrogen? OH. And we went from having 3+, but we took away a plus. So what's the charge? 2+. And the state is still aqueous. And what does water become? Well, we end up with H3O+. So when iron hydrolyzes, it produces H3O+, meaning the solution, will it be acidic or basic or neutral? If it produces H3O+, it will be acidic. So when you're determining whether a solution is acidic, basic, or neutral, you're always going to look at what is produced at the end. Okay, did you get hydrogen or did you get hydroxide? Did you get hydronium or did you get hydroxide? Could you please write the hydrolysis equation for ammonium? The reaction of the ion with water. Okay, so we have NH4 plus, we have water. What do we get as our products? NH4OH.
Really far out. It's an NH2H3O.
Who's going to do the donating of the proton? NH4 is going to donate the proton. So we're going to end up with NH3 plus H3O plus. Is this solution going to be acidic or basic? It's going to be acidic. Since it produces H3O plus, it will be acidic. Sometimes people are like, oh, it made a base. NH3 is a base. It must be basic. No, 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 no. Whatever it produces in terms of hydronium or hydroxide tells you whether it is acidic or basic. Every time you have an acid, it produces its conjugate base, right? But just because you have HCl, because it produces its conjugate base, that does not mean the solution is basic. It just means that you've made the conjugate base. Cationic hydrolysis. So positive ions always produces acidic solution. Could you please write the hydrolysis reaction for a solution containing chromium 3+? Is your phone helping you with your chemistry? Okay. Feel free to use your pink sheet to help you with this one if you need. Anybody need a pink sheet? No. So like that, and then react that with water. And then reaction water. Because, hydrolysis, like, is the reaction time. Yeah. Anytime you have iron or aluminum or chromium, remember you can look on your chart and say, I'm going to have CrH2O6. And because it is hydrolysis, remember that is the reaction of an ion with water. You have to have water as a reactant. And if you forget how this works, just look on your chart. It gives it to you. Oops. Okay. And if you have trouble with that, remember, you don't need to memorize it. You just need to go here and say, ah, it is written down for me. Yeah? It's right there. Okay? All right. Next. Okay. What am I doing? Brain. Going back here. That's what I'm doing. There we go. If cations produce acidic solution, what do anions produce? Basic solution. Most of the time. Usually. Okay? However, there are also amphiprotic anions, and they can produce either acidic or basic solutions, and that is going to depend on their relative Ka and Kb values. Okay? So anions are usually basic unless they are amphiprotic. How do you know you have an amphiprotic anion? It's not going to be positive if it has an H and a negative charge. Okay, so let's take a look at some anions. We'll start with one that is not amphiprotic, and then we will move on. So KF. What kind of a substance is KF? Is KF an acid, a base, or a salt? It is a salt. And therefore, if you are asked if it is acidic, basic, or neutral, what is the first thing you have to do? You have to dissociate it. You ask yourself, who are the ions? So you do the dissociation. Who are the ions? It dissociates into K plus and F minus. Does K plus hydrolyze? No, why not? It's a metal and it's not feel creepy, right? Does F minus hydrolyze? Try it out. You can try writing it, see what you get. Try writing your products for F minus plus water. Who do we get as products? HF plus OH minus. That's the only thing it can do. Fluoride cannot donate a proton, so that's what we get. What type of an acid is HF? HF is weak. All the other halogens, halide acids are strong. HCl, HBr, HI, but HF is weak. And you can go look it up on your table, and it is in the weak area. Okay? So HF is weak. So do we get this reaction? Yes. So this equilibrium can be set up. So hydrolysis does occur. What did we produce that makes it acidic or basic? Take a look at your two products. Which one of them makes it acidic or basic? The OH is what's important, and the OH makes it basic. So we made OH, and therefore the solution is basic. So assuming you do not have a cation that hydrolyzes, if you are only looking at the anion, if the conjugate acid is weak, then you will get anionic hydrolysis, and the solution will be basic. But if the conjugate acid is strong, you will not get anionic hydrolysis and the solution will be neutral. So let's take a look at NaCN. Can you guys do this on your own? Okay, give it a try. All right. Hopefully you found the ions Na plus, NaCN dissociates into Na plus and Cn minus. Sodium is a metal, no. Potential hydrolysis reaction, Cn. What do we have to react with it if it's hydrolysis? Water. And we end up with HCN and OH minus. What do we ask ourselves about the products? Yeah, is this strong or weak? It is weak. Therefore, does this reaction take place? Yes. Therefore, does hydrolysis occur? Yes. What did we produce? We produced OH minus, and therefore the solution will be basic. Now, why do I have this over here? Because maybe that would have been an option, but we didn't need that one this time, okay? You don't have to fill it in because it was just if anionic hydrolysis does not occur, you would have filled that in, but it did occur, so we don't fill it in, okay? Try the next one, please. Okay, so this one says if anionic hydrolysis was yeah. I mean, it's true that if it did, you know, you get that, but it doesn't.
Yeah, well, you know what? So, actually, and for and well,
NaCN is a salt. If it's not an acid or a base, it's a salt. Unless it's a molecular compound, which people will be like OH.
yeah,
Okay, you say, so we can use it in our water. Because you're not ready to control it.
Oh, yeah.
Yes. And then you're asking yourself,
Oh, and it does not.
and it does not,
Yeah, not
It's like the compound.
Is it one of those? No. No. Usually it's the cat on the answer is. Yeah, there's one they go to.
Okay.
When you have the side, right reaction, it does the acid, the acid. If the acid is strong, doesn't happen. If the acid is weak, it does. Okay.
I'm all right.
You can just say no. I'm going to say no, it's not feel creepy, and it's not NH4 plus. Those are the only 4 cations that hydrolyze. So if it's not one of those 4, it's not going to hydrolyze. Now, if you are able to just say, I know that the conjugate acid of Br minus is HBr, so it will not hydrolyze, you don't have to go through this next step. Does that make sense? So you can just be like, I know it doesn't, but we're going to do it just for completion's sake. So if you're having trouble seeing, will it hydrolyze or no, try it out. See, does it hydrolyze? And you're going to say, does it hydrolyze? If it did, we would get HBr and OH minus. And then we have to ask ourselves, what is the acid formed? It's HBr. Is it strong or is it weak? It is strong. And if it is strong, sorry, I've forgotten O in there, does anionic hydrolysis occur? No. So you can just ignore if anionic hydrolysis does occur because it's obviously not. And it does not, so it will be neutral. Try the next one. It does not have scaffolding for you. You get to do this one flying solo. If you have NO2, but it's do not take the entire salt. Just the reaction ion with water. So you just split it up and say, I get really strong. Yeah. Now, if you were doing this for a multiple choice question, you could just be like, once you've gotten a lot of experience with it, you won't be at that point right now, but you can just say strontium doesn't, it's not one of those four. And you could look at NO2 and you could say, NO2, its conjugate acid is weak, therefore it will hydrolyze, and I know that anions make basic solutions. So that would be how to do it for a multiple choice. But doing it this way allows you to see everything while you're getting used to it. One thing I saw a few people doing, and I see this all the time, what's wrong with that?
Oh, that's the hydrogen and the hydrolysis.
That is the salt. Never put the salt straight with water. You have to separate it into ions first. If you try and do this, you'll just end up digging yourself a pit of messiness that will not work out for you. Okay, you cannot do it that way. All right. Common error alert. Ooga, ooga, ooga. People stay talking through that. I'm shocked. Okay. That's all right. Shh. I said this before, but it's in here again because I think it's really important. Sometimes people will be like, I have F minus and I made a weak acid, therefore my solution is acidic. Is that true? No, because what matters is whether you make hydroxide or hydronium. So always ask yourself, did I make hydroxide or did I make hydronium? Not did I make an acid or a base. You're always going to make the thing that it's not, right? You're going to make a base if the solution is acidic. You're going to make an acid if the solution is basic. So don't look at that. Okay, amphiprotic ions. Amphiprotic ions must have an H and a negative charge. So if we take our NaHCO3, it dissociates into Na plus and HCO3 minus. Na does not hydrolyze, we know that by now. And HCO3, it could donate a proton, and it can accept a proton. How many HCO3s do you think we have in a solution of sodium bicarbonate? Like a few, a ton, how many? Not very many, many. Is it going to be just one? Am I just going to have one of these? One each? No, I'm going to have lots. If I have made a solution of something, there will be lots of solvent, yes? There will be millions of these. Why do I stress that? Because that means that some of them will accept protons and some of them will donate protons. It's just that more of them will do one than the other, depending on the strength of the acid, the strength of that anion as an acid, and its strength as a base. So what you can do then is you can say, okay, well, it could accept a proton, or it could donate a proton. And you could be making OH minus, or you could be making H3O plus. And it does both, but it does one more than the other. How could you tell what it does more?
You're being more of an acid than H2O.
HCO3 is more of an acid than H2O, but it's also more of a base than H2O. So that doesn't help. We compare the Ka and the This is not rocket science, people. Take that, yes. So compare the Ka and the Kb for HCO3. So now what you're going to do is you're going to go look up Ka. Of HCO3. Go look it up. I should hear lots of paper flipping. Ka of HCO3 is 5.6 times 10 to the negative 11. Is there a table where you can look up Kb? No. How do you find Kb? What's the formula for finding a Kb? Tell your partner, what's the formula for finding a Kb?
Yeah, the content that I think was. Is it right?
There's a formula. Do you guys remember it?
KW over KA.
Kw over Ka. Now, you'll notice I've left a little bit of space here. Don't write this next bit down. Do not write this next bit down. Are we happy with what I've written?
We need the conjugate acid of it.
We need the Ka of the conjugate acid, not the Ka of HCO3. So we want the Ka of the conjugate acid. Who is the conjugate acid? H2CO3. This is good reminder for tomorrow's quiz, yes? Yeah, there's a quiz tomorrow. Yeah? Okay. Look, quiz Friday, May 27th on 5.1 and 5.2, indicators of B. Okay. And that one is done. Am I done my question?
On the KB.
I found the Ka. I have found the Kb. What do I need to do with that? I need to compare them. So what I need to do then is I need to say that which one is bigger? KB is greater than KA. Therefore, what? Actually, you know what? I should, if I'm being really good about this, I should write that the KB of HCO3 minus is greater than the KA of HCO3 minus.
For the base and acid.
And therefore the solution will be basic. Okay? Now, if you were doing this on a multiple choice question, you don't have to do all that work. Okay? Multiple choice, I don't know how they learn anything. Don't listen. That's okay. Okay. There's a yakety, yakety, yak. All right. Let's go to our data booklet. And let's look up okay. Just judging from their position on the table, is HCO3 minus, it's circled in red, is it stronger as a base or is it stronger as an acid? It's stronger as a base because it is closer to the strong bases. This is very, very far from the strong acid. So if you were just doing it on a multiple choice, you could just do it visually. Yeah? But if it's a written response, you're probably going to be asked to justify your answer using calculations. And therefore, you would need to actually calculate the KB and compare it with KA. All right. Okay. Please try the next one on your own. That one is crazy. Have fun with it. And it also asks what is the predominant hydrolysis reaction. So put a box around that one once you have figured it out. What does predominant mean? Predominant means main. If you think about it, your dominant hand is the one that you mainly use, yes? Yeah.
Okay, and this one we can probably just write the let statement out loud. So
You don't need to write a let statement. You're not figuring out a pH.
No, let that long thing be B, so we have to.
Oh, yeah, you could do that.
Sorry, I will look.
Isn't it instantly more basic? Because oh no.
Yeah, yeah. Exactly. Yeah. Oh, yeah. Really? Yeah, he did.
Okay, did you guys get what I got? Okay, did you notice that H2C6H5O7 was amphiprotic?
Yeah.
Okay, whenever you have an anion, always check to see if it's amphiprotic. Okay, check for your anion. Is it amphiprotic? If it is, you need to compare its Ka and its Kb. Don't forget, when you're calculating Kb, it's always Kw over Ka of the conjugate acid. So instead of H2, C6H5O7 is H3, C6H5O7. And the Ka in this case is greater than the Kb. All right, and you guys have a quiz tomorrow, so study for that.